Hi scholars, please make notes. We will talk about alternating series. So first, let me remind you what alternating series are. They really alternate the sign. So we can either start from minus b1 plus b2 and so on, or plus b2 minus b plus I'm sorry, plus b1 minus b2 and so on. So, and we're interested whether an alternating series converges or diverges. So first, alternating series convergence test. We spoke about this in the class. So we are checking three things. First of all, if it's really alternating series, so if Bn is greater than 0, right? Now, we want Bn to be ultimately decreasing sequence. So it's okay if it's less or equal, but we want from some term monotonically decreasing sequence of Bn. And then, of course, we want limit Bn to be 0, and this part is actually built-in divergence test. If it's not 0, then the series will diverge, right? Now, what's important to know is that alternating series convergence test is sufficient, which means that if your series passes the test, it's gonna converge. But you can come up with other series that will not pass this test, but they will still also converge. So it only shows convergence, it actually doesn't show divergence unless number 3 is not fulfilled. Then it shows divergence, but it's actually a divergence test that shows divergence, right? Okay. Now we are going to alternating series estimation theorem. And for this, I want first to introduce some terms or remind you some terms. So if we have alternating series and it converges, so this sum converges to some finite sum S, then we can rewrite S as, let's say, remember partial sums. Let's say we will take the first 4 terms, and that will be S4, partial sum, right? S4. And we can also take the remainder and say that this is gonna be R4, and we will use R for remainder. Okay. So therefore, we can say that S is equal to S4 plus R4. Or we can say that S is equal to nth partial sum plus the remainder from nth partial sum. Okay, so now that we are clear with the terminology, let's introduce alternating series estimation theorem. This theorem only works for alternating series. So, if we have alternating series with Bn greater than 0, which means it's really alternating series, then we have, note that this is strict for all n. So it's monotonically decreasing starting from the very first term of the series, and of course built-in divergence test, which means that we have converging alternating series. Then if we want to estimate the true value of the sum by Sn, we know that the error of this estimation will be less or equal than B sub n plus first. And by the way, the absolute value of S minus S sub n will be exactly r sub n, right? And r sub n, the first term is r sub n, is bn plus first. So let's look here. This is my r sub 4. The first term is b5, right? And that's the largest term. And then we have, remember how we're going to have jumping with decreasing amplitude, right? Okay, so now we want to do an example on alternating series estimation theorem. So here is my example, and it's done. I will do it first different than it's done in the book, because in the book it's they use some confusing and strictly incorrect ideas, and I will give it to you how it will be presented to you on the exam. Okay, so example, find the sum of the series, alternating series with error that got to be less than 10 to the minus third. So let's write out what they gave us first. So 0 factorial by definition is equal to 1, and this is one of strange mathematical definitions that you have to know. And what do we need to find? We need to find how many terms n we have to add up so that s minus s sub n is less than 10 to the minus third. And let me rewrite it as 1 over 1,000. Okay, so what do I know about s minus sn? I know that it's less or equal than bn plus first, right? So bn plus first better be less, strictly less than 1 over 1,000. And this is what I'm gonna use to find n, right? Okay, so let's start with 5. So we would have b n is 1 over let's say 5 factorial, and 5 factorial is 1 times 2 times 3 times 4 times 5, and it's going to be 1 over 120. Is it less than 1,000? No. So we can see that we want to find b sub n plus 1 is equal to 1 over n plus 1 factorial, and that got to be less than 1 over 1,000. So n plus 1 factorial got to be greater than 1,000. Okay, so this is 120, so how about 6 factorial? It's 120 times 6, right? So that is going to be 720. Still not greater. How about 7 factorial? It's 720 times 7. That is actually gonna be 5,040, and ta-da! It's greater than 1,000. So n plus 1, note, is equal to 7. It's not n is equal to 7, it's n plus 1. Therefore, if we will compute S6, then S minus S6 will be less or equal than 1 over 7 factorial, which is less than 1 over 1,000, right? So this is what we got. So now we have to compute S sub 6. And you can already see that it's not something that I can give you on the exam, but I can give you the problem to find how many terms you need to add, right? Okay, so S sub 6 is gonna be, okay, the first term, I'm looking here, the first term is 1 over 1, so 1. The second term is minus 1. Then I will have plus 1 over 2 factorial is 1/2, minus 1 over 3 factorial is 2 times 3 is 6. Then plus 1 over 4 factorial is 6 times 4, 24. And then I have this factorial. So I will have minus 1 over 5 factorial 120, and then plus 1 over 720. And I think the textbook says that this is approximately equal to 0.368056. So this is the answer that you give. No, on the exam I will probably just ask you what is n, and on the exam you would say, in this particular case, you would say n is equal to 6, right? Now, in the textbook, they told you that they want you to find this estimation of sum correct to 3 decimal points. So, and the book thinks that it means that you can have, so your sum is equal to whatever you have here, and then this is the first decimal, second and third, and then you can have your error could change already starting from the fourth, right? So you want your error to be 0.000, and then actually they are open to consider. Which is kind of not how a scientist would go with 3 decimal points. A scientist would say that your error should be less than 0.000, and then they would put 1 here. But the book says, okay, we got that b7th is equal to 1 over 5040, and it's less than 1 over 5000, which is equal to 0.0002. And you can see that because this number, the sum, has 0 in the fourth place, the book says, oh, this is just what we need, because if we, with this error, we will not change the first 3 places. But what if we got 9 here, right? If we had 9 here, then this error would change. So that's why, so the book is a bit inconsistent, but you have to do the homework using the textbook, right, on WebAssign. So, so I hope that you will figure out how to proceed. So they are just open to consideration after the whatever number of decimal points they want you to have accuracy to. Okay, that's it. I'll make a quiz on this lecture note. See you in class.